Okay. Hello everyone. I'm Mélissa from the University of Dijon and I'm a PhD student in geography. So today I'm going to talk to you about how we can make the link between our researches, especially in the vegetation and the impact on the urban cooling and the urban planning. So as we know, thanks to a lot of research, there is a link between the urban vegetation and the cooling in the cities and the impact on the UHI effects. But as a geographer, I'm often used to work with urban planning, and the question they always have is where I am supposed to put the vegetation, what is the impact on my own city, and where I'm supposed to put the money and the efforts to vegetalize the city. This is a question that we find also in some reviewing papers, such as the one of Bowler and Knight, for example. And today, thanks to the last developments, for example, on the meso-NH and TEP surface models, we are now able to modelize the vegetation at a fine scale in the city. So the question is how to model a realistic scenario at a fine scale with vegetation with this kind of model. And does it work and does it give the results we need to speak with the urban planning? So what you can know about it is just that we work with a realistic case over the 2020 heat waves that we have in Dijon from the 6th to the 10th August. And we work with three nested domains. The last one, the simulation domains, it's at a 150 meters resolution. So we work with the Dijon city and surroundings. What you have to know is that it's on the east of France, and even if it's not a really warm place, we have a UHI effect in this city during the summer. This city is an ideal seat for this study because we have good relationships with the urban planning, and also because we have, since 2014, implemented a network of temperature and humidity sensors at a really fine scale. Here in orange, you have all the places where we put the sensors. So it enables us to compare modelization and observation at a really fine scale. And this is really interesting here. So you can see it's the Mustard Dijon network if you want to know more about it. So here, thanks to the sensors, we are able to study the UHI effects at a fine scale. You can see here a map that we created with these results. So you can see here the UHI effects. There is also some warm space here. Actually, it's in the forest on the coast on Dijon. We can talk about it later if you want. So the first step of this work is to create a reference simulation that is as realistic as possible. Because we want to add vegetation after, and if we don't have a good soil occupation in this reference simulation, there is no point. To create it, we have in France a national database that is called BDTopo. That represents really good for the building, for the water surfaces and the roads. But for the vegetation, there is a problem in this database. Here you can see in green the vegetalized areas that are represented. We only have public vegetation in this database, and only high vegetation and some of the high vegetation existing. For example, here you have street trees that are not represented here. So we needed first to create our own vegetalized database. We created this with Pleiad data. We created a mask with the MSAVI method. And then we applied this mask to LiDAR data in order to add the height of the vegetation. So it gives this kind of results. another example. So to work with urban planning, this kind of databases are really useful. And for our modelization, it gives us per mesh grid the amount of low and high vegetation. And this is what we need with depth surface. This work is a sensitivity study of the depth surface model to a better representation of the vegetation. And here you have a bit of the results. So in blue, you have the modelization with only the BD topo, and in red, you have BD topo plus the vegetation database that we created. So we have results that are far more closer to the Mustard Dijon observations. You can see that it's better during the day than during the night. That's normal. We have in Dijon the coast that creates some problems in the modelization. It's good to make wine, but not for the modelization. We have inversions, katabatic inversions, that are a bit of a problem here. So we have these reference simulations that is closer to the reality, and now we know where the simulation is good or not. In the second part, we are going to compare a green scenario to this simulation. So for that, we need to create a vegetation scenario at a fine scale with the urban planning. To do this, we identified three axes that could be vegetalized. The first one are public spaces such as the streets or the places. The second one are the industrial and commercial sites, the parking lots, for example. For these two axes, we had a GIS method of systematic vegetalization, and we let just the places for the vehicle to pass. The third axis are the private yards, and this is often something that is put aside in the bibliography. But in a city like Dijon, private yards are a big potential. And for that, I developed a GIS method with a QGIS Python script that creates a module of automatic vegetation, and we can apply this to every city in France. It's based on the urban planning rules we have in France. Here you have a closer of this result. So at the scale of the entire domain of modelization, it gives around 25% trace of vegetation, and it's validated by the urban planning. So about the results of modelization, we have a mean of lower, we have a cooling effect of the air temperature, but this cooling effect is not the best results we have here. This confirms other works that we have seen here in the ICUC. We decided to make a closer look at the difference we can have between night and days. So first, about the result during the day, you have here in the blue points, this is the mesh grid where we only had low vegetation. We separated the adding of low and high vegetation here because they are different impacts. So about low vegetation, what we can see is that it's a bit correlated with air temperature cooling. This is because of the latent heat flux. This latent heat flux is causing a high UTCI, a bit of a high UTCI. Here you have the point where we added also high vegetation. And you can see that high vegetation is correlated with a low UTCI by 6 degrees. This is the biggest results we have here that confirms the bibliography. This is because of the shadow, of course. For the night, we have, just like the day, the low vegetation that is correlated with air cooling of air temperature. And this is also responsible of a lower UTCI because we have less impervious surfaces, of course. For the high vegetation, we can see that the air temperature is not impacted by more high vegetation, but the UTCI is slightly warmer with high vegetation here. And this is because of radiant temperature. Here we can see that in the model that we are using, there is a big heat storage effect. And maybe we are going to do a sensitivity study about the implementation of the high vegetation databases in the TERP-surface model, because we think there is a bit of a surestimation of the heat storage effect here. On the UHI effect, we can see that, so that's a map of the difference between the UHI effects with the reference simulation and the green scenario. So as we can see, it's highly correlated with the low vegetation that we did, especially in the commercial and industrial sites. And here you have the difference between green scenario and the reference, and we can see that it reduces the UHI effect. So what can you take home of this presentation? Maybe the fact that GIS methods are an efficient way to make the link between our research and urban planning. And this is the point of what we do after all. Trees have definitely the biggest impact on cooling, especially over UTCI. And maybe this is the more important thing in the streets, because this is where pedestrians are during the day. But during the night, it seems that the low vegetation is a good way to compensate for the heat storage effect and the UHI effect too. After this work, we are going to use this methodology in order to make forecasting scenarios with the city of Dijon at the scale of 2050 or 2100. Thank you for your attention, and I want to thank also all the contributors of this presentation that are from France mostly, Dijon, Besançon, Toulouse, and the city of Dijon, of course. Thank you.
Any questions? Any questions or comments? Any? Yep. Question?
Yeah, it's not a question, but could you just go back one slide?
Yeah.
Here?